Let it out. Here we go. I'll calm down too. 9, 6. Number 8, 6 ways. Number 10, 3 ways. Number 12, 4 ways. Number 14, 6 ways. And these were the counting up ones from what you see. Number 20, hopefully you didn't count those up, 4,096 ways. Because there were 12 blanks, 2 options each. Wasn't this the true-false one? Maybe not. I'm just guessing. True-false. How many answer choices are there? 2. So you can answer a true-false exam with 12 questions, 4,096 ways. Whoo, interesting, right? So the whole like random guessing thing? Okay. Now, random guessing on one question, you have a 50% chance, right? Better than a multiple choice test. But randomly guessing, getting 100%. Okay, number 24. You guys see the blanks? Weren't these 4-digit numbers with different characteristics? A lot like the 3-digit numbers in our notes. 9,000, 4,536, 4,000, 4,500. Right now, just grading. I have the book open. We can go look at the questions if you have them. But not right now. Just grading. 9,000, 4,536, 4,000, 4,500. Number 36. Order was important. 100 total, arranging 5. Plug it in your calculator. Done. 9,034,502,400. Number 46. Ooh, I can tell. I can tell. Were there repeats? Yeah, there were. There were repeats. Final answer, 34,650. Number 54. Order did not matter. Out of 10, choosing 7. 120. I know. If you have questions, we'll get to the book in a second. Nice thing is grading is fast on these. Number 58. Order did not matter. Out of 20, choosing 5. 15,504. Number 68, A and B. There were different blanks. I like this question. This is the one with like the facial recognition something, right? Somebody's trying to catch a perpetrator in a crime, a witness, can only remember certain features. Anyway, each blank was for the different features. How many options for each of the features you filled in? 1.335 times 10 to the 10 different faces are possible with that facial recognition system. Wow. Letter B. What if they knew these 2 blanks? I forget what the 2 features are, but what if they knew these? Which means they chose 1 for that blank, and they chose 1 for that blank. They didn't know these. If you were able, I think I remember what the 2 characteristics were. Hair and eyes. If you were able to say the hair color and say the eyes, what are the odds that you'll actually be able to, with the facial recognition system, find a person? You'd have to go through 691,530 different faces. Because it would generate all the ones with those hairs and eyes, and you have to scroll, 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 and hope something jumps out. That's even if you were able to identify those 2. Imagine a baseball cap, imagine glasses. Anyway. You had to choose, choose, choose from these 3 blanks still. Okay. Whew. Odds and evens. I'm ready. What'd you miss, and what do you want us to look at? Lainey, go ahead. 63. Okay. We can still do evens, guys. We're just going first to number 63, if I can get there. Come on, 63. Defective, oops, I apologize. Defective units. Okay, a shipment of, let me get down to 9.6 real fast. Here he is. Let me go here. Let me go back here, and let's steal him. 25 TV sets contain defective units. A set of 25. 25 total contains 3 bad ones. In how many ways can a vending company purchase 4 of these units and receive, bless you, bless you, bless you, all good, bless you. Let's start with all good. It's the easiest one. All good. How many ways can they do all good? Well, kiddos, they're getting 4 TVs. We don't care the order that they open them. We just care they open them, get them all out, plug them all in. How many are bad? Hopefully, in this one, all are good. None are bad. How many ways could that have happened? Order doesn't matter. They're getting 4 out of 22. There are only 22 possible good TVs. So out of 22 good ones, getting all 4 good ones, that would have been the answer for A. Letter B says getting 2 good units. Now here's where it gets tricky. Why am I going to do 2 blanks if they're getting 2 good ones? One good one, one good one? No. 2 good out of 22 getting 2, but what's the shipment that they're getting? So if they're getting 2 good, by default, what must have happened? 2 of them are good? What are the other 2 if they're not good? Bad. We're not going into broken and all that sort of stuff. 2 good. Well, the other 2 must have been bad. Okay. And 2, how many are bad? Out of 3, getting 2 of them. So if they got exactly 2 good units, the other 2 must have been bad. So 2 good and 2 bad. Order doesn't matter. Send you guys at least 2 good units. Does the 2 good units, is that one way of having at least 2 good units? Yeah. At least 2 means you could have gotten 2. But at least 2 means you could have also gotten 3 good units. Or is addition. We haven't gotten to it super specifically yet, but or is because you take all these options, or, oh, it could have happened other ways. Add those in. Or, oh, it could have happened this way. Add those in. So we're adding in, what if out of the 22 good ones you got 3? But wait, if you got 3 good ones, what else does that mean? You got 4 TVs, so how many bad ones must you have gotten? 1 out of the 3. Or, how else could you have had at least 2 good units? 2 good, 3 good, or 4 good. Dun, 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 dun. Do you see how the at least makes things harder? Makes things harder? There was another way of, hold on. And it worked. Here's the other way. You could have said, that was a fluke. There was another way of doing it, but that wouldn't have been it. The other way of doing it would have been to take the, nope, that wouldn't be it either. Everything that I'm thinking about has to do with probability, and those tricks won't work because we're just doing how many. I think it was a fluke. It was a nice fluke, but I think that's a fluke. But one more time, you did 22C4, so you acted as though you got 25C4. So out of the television sets, how many groups are there of getting... Oh, okay. No. That way makes sense. I thought you said 22C4. Okay. Yeah, that way makes sense. So out of all 25, Jackie saw or asked or found, what are all the groups total? What are all the groups total? 25C4. What are all the different ways all those TVs could be grouped? And then she subtracted. What's the one way? She had to take away something. What's the one way it wouldn't be or it wouldn't have at least 2 good units? If it didn't have at least 2 good, that means 1 good. You only had 1 good and 3 bad, which would be 22C1 and 3C3. 3 bad and 22 good. And technically, you would have also had to think about, wait a minute, what if you had no good units? But hold on. Sorry, I must be a C. No good units? Hold on. By default, doesn't that mean you had to have gotten 4 bad ones? Can you get 4 if there are only 3? So that's not even an option. And Jackie, here's a dealio. And maybe you realize this. Getting the 3 bad ones, if there are only 3 and you got all 3, that's only 1 grouping. So then the only thing you had to worry about was, okay, well, there were 22 different ways to get that 1 good one with that. So if that made sense, then yeah, that works. That works. Okay, other questions? AJ. 24D. Was that one of those like 4-digit number-y ones? Okay. Oops. Yeah, the characteristics can get kind of funny, right? So 24D, the leading digit can't be 0 was a lot like yesterday, so that's the beginning of the characteristics, but then it also said, and the number must be even. Didn't we have one similar yesterday where we were talking about multiples of 5? Like a special characteristic of the number? So it's a 4-digit number, so 4 blanks is one way of, there we go, is one way of doing it. The leading digit cannot be 0. What was your first number of options for the first blank, AJ? Good. Why must this be 10 and 10 and 0, 2, 4, 6, 8? To be an even, the ones digit has to be a 0, a 2, a 4, a 6, or an 8. I don't care about the rest, except they told me 0 can't start it. So don't care, don't care. The only options are, oops, the ones that would make it even. So that'd be, yeah, 4,500. Abby. B. The leading digit cannot be 0. Oh, there are napkins at the front, Josh. It'll be nicer on your poor little nose. The leading digit cannot be 0, and repetition of digits is allowed. If repetition of digits is allowed, we have that 9 to begin with again. But I don't care about these guys. I don't have to do the counting thing because I can use, according to them, oh, no repetition. Sorry. I read repetition is allowed. That would have been repetition is allowed. If repetition is not allowed, instead of there being 10 options, you just used a number. So now there's only 9 options. For this one, instead of 10 options, you just use 2 numbers, like by putting one in the thousands place and one in the hundreds place. Now there's only 8. And then instead of 10, you've just used 3 numbers. There's only 7. So think like number tiles for all the numbers, and you can't use the same one twice. Yeah. Any other questions? Number 36. Like the problem 36? Okay. Be careful on these because some of them, there is, and I'm not saying 36 is this way, but just in general for everybody. Oh, never mind. That's easy. I was going to say in probability in general, there aren't always ways, like with the blanks, there's not always a way to tell your calculator, please do this math for me if you guys can't figure out the blanks first. Just a quick warning. But number 36 definitely can do it on the calculator. This one, you guys needed the factorial formula. So you might want to just right now, do I like factorial formulas? Asking on a test at least once? Yeah. So the NCR one you learned in the beginning of chapter 9, it's come back, and the NPR one has now come up. Should maybe you guys this weekend kind of be working on those factorial formulas, figuring there'll be a blank on the quiz on Tuesday. Does that make sense? Okay, but using your calculator, I'll probably let you have your calculator the whole time. So maybe you'll have to fill some blanks in for me to get all the points, but know how to use your calculator. AJ, math, go over to prob for probability. Put the 100, NPR, put the 5. Good. Permutation. Some of it's like natural in the sense of if you're talking about the arrangements of a word or arrangements of letters. If you were to switch 2 letters, it's a new arrangement, like you kind of would realize that. Or a license plate, like Jacob was asking yesterday, if 2 things are switched on a license plate, it's a different license plate. So if by switching the order, it makes it different, whatever they're talking about, it's going to be a P, permutation, order matters. A seating chart, if you switch 2 kids, it's a different seating chart. Does that make sense? If you see anything that indicates orders, arrangement, orderings, seating chart in your head, you know that there is an order where things need to be in order. But if it's talking about choosing people for a committee, or how many groups, or how many hands of cards, if I were to switch 2 cards, you still have the same hand. If I were to switch where 2 people are sitting in a group or a committee, it's still the same group. Does that make sense? So some of it is just kind of like a natural, and in section 9.7, we'll deal with it more, with more problems. In this one, the jury selection. The jury selection, how many different ways can a jury of 12 people be randomly selected from a group of 40 people? In how many ways? You might be like, permutation, order matters. But then it's like, no. You're just getting 12 people out of 40. You're just caring about the group of people on the jury, not, even though it might eventually be important, not who was chosen first, second, third, fourth in the whole jury selection process, just how many different possible groups of people. So combination. So it's just kind of understanding and looking for, does it matter if I switch? Okay, any other questions? 9-7. Let's go. 9-7 answers will be generally small. Will be generally fractions or decimals, and the decimals can be written as percentages, right? Because now we're talking about the odds. Now we're talking about the chances. Now we're talking about the percentages as to how often something could occur. Oh, hey, I had that one already. Oops, I forgot. Oops, hey, I had that one ready too. You guys didn't need it. Now, let me have you start taking notes. That page that you just saw a second ago is basically just a recap, kind of dealing with Jackie's question. So we'll go back and look at it, but I don't need you guys taking notes on that as I answer AJ's question. AJ, go. Oh, I was seeing. That's what I was saying you could use. You could do 100 probability NPI. So that's the answer you want to get. But you should be able to get there using this. So hold on, let's see what you're doing. You're just going over to factorial. Hold on, for permutation, you're not dividing by n minus r times r factorials. That's combination. R factorial. Oh, the number's too big. That's weird. The problem is not that it can't, not that you're writing it wrong. The problem is, in order for the calculator to do it, it has to find 100 factorial, find 95 factorial, and divide, and it's like too big for me, because it is, it's huge. So look at what you can do instead. Can't you look at this and say, I'm smarter than the calculator. I know that these 1 through 95 don't matter. It's just going to be So it's not that you were putting it in wrong, it's just like it's too much for me. Because the calculator's not doing that whole canceling thing, it would literally have to do all that work. And then, if you can imagine that's what's left, put the other 95 in, that thing's brutally big. Okay, section 9.7, probability, the chances of. You can also say the odds of. You can also say so chances is one way of saying it. Odds, another way of saying it. Probability, another way of saying it. What is the probability? What are the chances? What are the odds? All good ways of wording questions for 9.7. Now, guys, there are going to be formulas in this section, and they are going to be helpful to some extent. But ultimately, for the quiz, besides the factorial formulas for the most part, and you're using your calculator, ultimately, you just have to be able to face the problems one at a time and know what to do. So don't get too stuck in all the notation and all the formulas and all that jazz. Outcomes. You guys hopefully know what an outcome is talking about. How many different possible outcomes? Outcomes is how the trial, let's just do it this way. The results of a trial. I was going to say how a trial could end up, but that's kind of lame. So a better way is saying the results, the possible results of a trial. Now you can have favorable outcomes or you can have unfavorable outcomes. Favorable would be like we talked about in the homework that probability randomly got brought up in section 9.5. Or yeah, section 9.5. They called them successes and failures. So then we could say for outcomes, a success would be a favorable outcome for whatever they're stating. Doesn't mean it's your favorable outcome. For instance, maybe they say, hey, what are the chances of you getting this many heads? You're like, well, I don't want heads, I want tails. Well, it might not be a success for you, but it's a success for what they're asking. So favorable outcome, and then a failure, like we were talking about, would be the unfavorable outcome. For probability, we're going to have to figure out the favorable outcomes over the sample space. How many favorable outcomes are possible over how many total outcomes are possible? So the sample space are just the total outcomes, which would be the favorable plus the unfavorable. It's all of them put together. The sample space is talking about, I don't care whether you're getting heads or whether you're getting tails. What are all the different ways that this could end up? What are all the different possible combinations? What are all the different possible permutations? Not for a specific characteristic, just in general. What are all the different possible outcomes? So, if we're trying to find the probability of E being the event, this is like function notation, like f of x, but it's p of E. Trying to find the probability of some E occurring, some event. E, this event, we're talking about the successes. They are establishing what the success is going to be, what the favorable outcome is going to be. Whether or not it's favorable to you personally, when they say E, okay, in our heads we'll say, okay, that's the favorable, that's the desired, that's what they're asking for. So then up here we could say N of E is the number of ways something can happen, the number of favorable outcomes over the number of the sample space. That's what the S stands for. So ultimately, the number of ways the event could occur over the number of ways in the sample space. This is just of, it's not times, no multiplications going on. It's just like a mathematical way of saying, hey, take what you were finding in 9-6 for how many ways the favorable could result or how many ways this could happen. But you have to divide by the total number of ways. So favorable outcomes divided by total outcomes. Does that kind of make sense? Favorable outcomes divided by total outcomes, which is how when I asked you for that example we did on the board yesterday, and then we led into Noah's making the free throws, but before that we were talking about flipping a coin. Didn't need to figure out the 88% based on his stats, just like the coin. And I said, what are the odds of getting ahead in one flip of a coin? What did you guys think? 50%. Why? Favorable outcomes, you get the heads. 1 out of total possible outcomes, head or tail. 2. 1 out of 2, 50%. Favorable out of total. Does that make sense? Favorable out of total possible. Chris?
Now, I know this is going to sound like a stupid question.
Go ahead.
Kind of genuine. Like, even though, like, the probability of it is extremely low, would you, like, if you're, like, really thinking about it, would you have to factor in the fact that, like, it could land on its side?
Well, here's the idea. What you just said is, even though the probability is significantly low, we would say the probability of it landing on its side, or like leaned up against the leg of a chair, which, okay, if I'm flipping it here, there's different objects a coin could land on, like partially, so we're not going to, if we're just open space flipping a coin, okay? Probability of it landing on its head, we would say it's insignificantly low. Meaning, could happen, but it's so insignificantly low, we won't factor it in. Does that make sense? Yeah. So you're right, there could be a 0.0000, but if you factor that in, you would round and it wouldn't be there. Does that make sense? Okay. But that's also another reason that probabilities, statistics, are not truly predicting the future. Right? Probability and statistics do not truly predict the future. How can we actually see this? It's called the weather channel. And the chances of rain. Or the chances of whatever, fill in the blank. Now, that's not to mock them, because don't we all still look, well, should we all? Do at least your parents? Do some people at least still care about what the weather person is saying about the likelihood of good weather if they're thinking towards like their wedding that's supposed to be happening on Saturday and the weather says 100% chance of rain? They won't usually say that. 60% chance of rain. Will someone care about that? Yes. Why? It's better to know something, whether or not it's going to happen, to plan ahead, right? So we have to think statistics, planning ahead. They're helpful to plan ahead. However, some people that make a living or try to make a living or try to dig themselves out of a hole based on, well, there's a chance. Is that dangerous? Very. What am I talking about? Las Vegas, gambling in general, the lottery. Once again, I did not say that Mr. J counts cards. I said he'd love to talk to you about them. Anyway, we don't want to make light of this, kids, because literally entire families and companies have been ruined on someone taking a chance they thought could happen. People have based way too much on this, and it's dangerous. And some people have not even thought about the chances and still gambled way too much on something that in their head they were like, meh, it could happen. Let's do it. They just thought. Now, am I saying never take a chance on anything? No, it's not what I'm saying. To be honest, when you wake up in the morning and walk outside the door, you're taking a chance, aren't you? We don't know the future, only God does. But just be careful making light. Does that make sense? And be careful taking things lightly, because it is dangerous. Okay, all of that to say, this section, even though we are introducing it, even though it does help you hopefully for SAT stuff, etc., hopefully it does just make you take a quick second, I don't even know, some point in the future when you are being asked to take a chance, and just think, oh, is this wise? Is it not? We can't always tell. We can't always tell what's going to happen. We can't always predict exactly how something's going to turn out. Even if we know the chances are favorable, which at least that's helping add some wisdom to your decision. If you're like, well, the odds are pretty good. But at the same time, there is no way of definitively telling the future and what's going to actually occur. And that comes back to Chris's thing with the coin landing on its edge. Or the Big Bang actually occurring. Ask a mathematician about the origin of the universe. Anyway, coming back. No, but be well-rounded. Be well-rounded. If you're actually curious, go look at a secular mathematician or statistician. It's interesting. Okay, if probability of E is equal to 0, then event E cannot occur. So, Chris, with the coin landing on its edge, I would never say the probability is 0. Never. I would say it's insignificantly small. 0.0. Right. But I would never say it's 0. But the calculator or your calculations at some point would treat it like 0 because of how insignificant it is. Probability of 0, it cannot occur. If I looked outside and it was raining, and I said the probability of it not raining today, what would you say? 0, because it's raining, right? Other than that, we can't really say much of anything is a probability of 0. Except, maybe, probability of waking up in the morning and my hair being blonde. If no one gets into my room and actually does it to me. Okay. But overnight? Anyway, there are a few things that maybe we could be like, the probability is 0, but coming back. If the probability were 0, we would say it can't occur. We would say that it is an impossible event. Are there other synonyms for impossible? Of course. You guys think of them. Let's move on. If the probability is 1, what would you guys say? Probability is 1. Some people are saying it's possible. Some people are saying it's significantly possible. And only one person said it will occur. Why? It will occur. What? It's a certain, sorry, wrong blank. It's a certain event. It's a guaranteed event. It will occur. If I look outside and it's raining, probability it rains today, 1. What? It's 100. It's 1.00. Oh, the probability is 1. That's 100% probability. Maybe you want to put that in parentheses. Because if probability is 1, some of you are still stuck on the big numbers from 9, 6. No, 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 no. Probability are decimals, right? So probability of a certain event would be 1.00, which is 100. Does that make sense? You toss 2 coins. What's the probability that both land heads up? Why is it 1/4? Some of you were able to say it's landing. So either it's heads, heads, or it's heads, tails, or it's tails, tails, or it's tails, heads. I just listed the only 4 possible, significantly possible, outcomes. How many of them has both landing heads up? 1 out of 4. Is 1/4 the probability? Yes. Is 25% the chances? Yes. Could you technically say they're the same? Yes. So in the back of the book might be a fraction. You put a percentage. Could you put or 0.25? Yes. Okay.
I never understood how you could like flip 10, maybe get 10 heads in a row, but on the 11th one, the chance of you getting heads or tails on the 11th one
It's the exact same.
It's still 50%, but what's the chance of you getting 11 heads in a row?
But here's the problem. Here's the problem. Your head is like, what are the chances of getting 11 in a row? But you've already gotten 10 in a row. That does not affect at all your chances of one more flip. So it's not so much what are the chances of getting all 11. That's not the point. The point is you've already gotten 10. You've already beaten the odds. But the chances of it happening again are still 50%. Now, if you're in a slot machine in Las Vegas that's been programmed, possibly, to let every whatevereth try be a win, well, that's something if you haven't won and you're like, oh, I'm bound to get that one that they let someone win just to keep the hope alive, right? That'd be different because probably most of those are rigged. But coming back, literally an event like that, you've already beaten the odds. On the next flip, you still have 50%. And this also has to do somewhat in, is it baseball where they talk a lot about like, oh, that batter's due. Good one for a. Now, that could be, just statistically speaking, technically that's impossible. However, if you know that player and you're using your background knowledge, right, you're using your information, that's a whole different thing. Think about the player who's been injured or they're getting stronger. There are different factors at play. But mathematically, statistically speaking, a player being due is impossible because of what you just said. Coming back, letter B. You draw 1 card, P.S. Old crime show from CBS, Numbers, very interesting show. You should look at it if you have any interest in seeing the mathematical behind the scenes. That could possibly be a part of something like, I don't know, crime fighting. Okay, you draw 1 card at random from a standard deck of playing cards. Why am I saying that? Because the whole player being due was part of a discussion on one of the episodes way back when. You draw 1 card at random from a standard deck of playing cards. His brother's an FBI agent. He's a mathematician. He's brought in to consult for cases. Okay. It's still dramatized for entertainment purposes. You draw 1 card at random from a standard deck of cards. Okay, hold on, wait. Cards. Some of you don't know cards. Sad, but true. So hold on real fast. You might need to write this down. A standard deck. P.S. We're almost never using jokers. It's just true. Standard deck of cards. How many total cards? Okay. How many suits? 4. Hold on. Parentheses. What are the different suits? Spades. Hold on. Who's red? What are the other ones? If there are 52 cards, stop. Split. 52 cards, split into 4. How many cards are in each suit? Okay, pause. The cards in the suit. How many face cards? Cards with faces on them. How many numbered cards? 9. There's no 0. 9 numbered. Good point. 2 to 10. It's like 1 to 9 is 2 to 10. It's still 9 cards. Okay. Standard deck. Let's go back. Optional. Fine. Optional. 2 jokers. Usually not being included when they say a standard deck. Well, never included when they say a standard deck. They might bring it in. You draw 1 card at random from a standard deck of playing cards. Wait, pause. Total possible. 52. What is the probability? Favorable outcome? Ace. How many are in the whole deck? Reduce it. 1 out of 13. Could you get a percentage? Sure. Time's too short. That'd be a 1. A 1 out of 52. Okay, a couple keywords for us to talk about. Probability of A and B occurring. Probability of A and B occurring. Now, here's where the other use of and comes in. There are a couple different ways of looking at this, so be careful. The probability of A and B occurring. One way of talking about A and B could be talking about one event or one trial, 2 characteristics simultaneously true. One way of talking about and is 2 characters, lo siento, 2 characteristics simultaneously true. So what if I was to talk about, with this whole standard deck of cards thing, what if I was to talk about black cards and clubs? And I was to say, what is the probability of, in a way, of a card and a club? So in a way you could use and, getting 1 card that's black and a club. That's one way of using and. 2 characteristics true at the same time. But how many cards are we still choosing? Just 1. So you have to think about how many black cards are there total. 26. How many clubs are there total? 13, but pause. Venn diagram. How many of the clubs are black? Oh, there's 13 in there. There's 0 out here, which means there are 13 other types of black cards. So what's the probability of getting a black club? 13 out of 52, or 1/4. What would make this a little bit more interesting? Well, what can we change this to be so not all 13 are in that category? Sure, a black even card. That just got exciting. How many even cards are there? Well, each suit has a 2, 4, 6, 8, 10. Each suit has 5. How many suits? 4. 4 times 5 is 20. So there are 20 total evens. That looks like a Z, lo siento. It's like a zuck almost. Even. There are, but hold on, how many of those 20 are black? 10 of them. 2 of those suits. Okay, it's a little more interesting. So how many even black cards are black even cards? So long story short, if you're picking 1 card that has more than 1 characteristic, could you use an and? Yes. But that's not what this is talking about. This is talking about the probability of 2 events, A and B. 2 events. Does that make sense, the difference? 1 card, this is one way of thinking about an and. This is just with 1 card or 1 event. But what if you have 2 events, A and B? If you have 2 events, A and B, you're going to go back to the fundamental counting principle and think, oh, probability of A times probability of B. Think of multiplying the 2 together. Now, there is a special time where we need to think of sometimes the probability of B after it has occurred B such that A? Remember how sometimes if we have no repetition is allowed, the next number gets changed from what it could have been? This is just saying, oh, sometimes you have to take into consideration if A happens, then B might change a little bit as to what it would naturally be. But if we have and, we're going to do multiplication. And we're going to end today with, not an example, but instead an or. Not an example, but an or. Probability of A or B occurring. Two events, A or B. Ors, you're going to do addition instead. But here's the struggle. Sometimes we can just say that A or B. There's a little symbol with, oops, nope, that's an and symbol. Hold on, pause. Give me just 1 sec. Maybe take a picture. You guys can grab this from offline. If I have A and B with a little bit of an overlap, if I were to add all the A and add all the B, didn't I just double count some? I have to subtract the overlap. But if they cannot happen at the same time, I don't have to subtract the overlap. For instance, probability of getting a queen or a red card. There are 2 red queens. Probability of getting a queen or an ace. Oh, there's no overlap. Bye, cool kids. I'll see you later. That's enough to get really good started on 9-7. But remember, you're going to have to persevere a little bit further than you would naturally do on a normal homework. Some of you are lazy and would just wait.
Next year,
You don't want to be on the video.